Okay, everyone, so this last example is going to take into account a lot of the stuff that we talked about so far. We have a luxury car with a weight of 4,400 newtons, traveling at 35 meters per second, and it comes to a stop in 100 meters. We want to know what is the braking force of the car in order to keep it from crashing into the wall. So the weight of the car is equal to mass times g, and we know that the weight is 4,400 newtons, so we can set that equal to m times g. Divide, and we can solve for the mass, and find that the mass of the car is equal to 448.98 kilograms. So now we know the mass. We know that the car was traveling at 35 meters per second. We know that it has to come to a stop at 100 meters. So we know the displacement is 100 meters. We know the initial and final velocity. And so from all of that, we can calculate the acceleration. From the acceleration and the mass of the car, we can determine the braking force of the car. So just writing everything down that we know that the mass is 448.98 kilograms. We know the final velocity is 0 meters per second. We know that the displacement again is 100 meters, and the initial velocity is 35 meters per second. Using the third kinematic equation, we can solve for the acceleration. We plug in the values that we already know. And then solve. We find that the acceleration is equal to negative 6.125 meters per second squared. Since we know the acceleration and we know the mass, we can determine the braking force by just saying that the force is equal to the mass times the acceleration. We find that the braking force is equal to negative 2,750 newtons.